Hi, everyone. My name is Danat Smon. I'm the head of global marketing at Fotelix. I'd like to welcome you all to our latest expert webinar series about ASAM recently approved OpenSCENARIO 2.0.0 standard. Our host for today is Sharon Rosenberg, Fotelix's solution architect and chief methodologist. Sharon is a world expert in verification and validation and author of books as well as blogs on the topic. Many of them are available on our website, where you can find also other resources as well as recordings of prior webinars. So I urge you to check them out. We're going to have a great webinar today, and I would like to remind you all that we open a Q&A channel, which you can see at the base of your screen. So please use that to send your questions, and Sharon will answer them at the end of the session. Sharon, please take it from here.
Hi, everybody. Thank you very much, Dan. Let me just maybe open my camera just to say hi. Can you see the camera or no? Okay. I cannot do that. So hi everybody. My name is Sharon Rosenberg, and without any other introduction, we'll just start with the material because we have a lot of it. So let's continue with that. About this webinar. So within our environment, our BNB environment, our requirements environment, there are multiple domain experts that are not necessarily programmers. They might be programming not 100% of the time, sometimes maybe 0% of the time, and in specific programming BNB scenarios. This could be requirement engineers, system architect, and managers. This could be very key individual, and we want to get better utilization of the entire team itself, and sometimes they're really critical. They're the one that to approve and confirm that we're doing the right thing, and this scenario is doing what we need to do according to our requirements. So they should be able to read OpenSCENARIO, and the full name is OpenSCENARIO v2.0. I'm going to call it OpenSCENARIO 2 within this webinar. So in order to understand the language, you need to understand the philosophy and the concept behind it. And this is bi-directional, so you'll be able to internalize the syntax better if you know the concept. The syntax will be straightforward, and you'll see that there's a lot of connection between them. So we'll start with that. We'll do it shortly, and then we'll move to the syntax itself. And here's the promise. So obviously, we're not going to go over all the syntax, all the possibilities, but we're going to give you enough of a start so you can continue from there. So the 10% that are critical, and you can complete the rest by intuition or learning and asking. So we will look at basic scenarios, be able to leverage ready-made scenarios for your project purposes. This is about the webinar, and I want to start with talking about the language itself and how we made it simple and easy to use. I'm talking about MSDL, but OpenSCENARIO is an ASAM standard. I'll talk about that later on. There's two programming styles. There is procedural, in which you specify the exact steps to get the result. Python and C++ are like that. There's another style which is declarative. So you say what you want without having to say how to do it. SQL, for those who know, are example like that. Using a metaphor, it's like to instruct a driver. You can tell it exactly when to turn. And sorry, there is a comment here that I might be a little bit weak on the voice side. Let me connect. And I can connect this. I hope you guys can hear me. So I'll continue, and with the hope that someone will notify me if you cannot. Okay, so back to where we were. Procedural. If it was a driver that you need to instruct, okay. Okay, thank you. I can see that there's no echo. Okay, so procedurally, this is where you instruct the driver where you want to go. So you really tell him where to drive, where to turn. You really need to know where you're going. And that's how you do it. Declarative, this is like you provide the address and you trust him to find a way of getting there. And maybe in ways you didn't know or thought of, but he will find a way and you don't need to do it. So these are the two styles, and we have to take a decision what to use. Which one would you choose for a language, for scenario language? If you need any other tip, so reminder of the requirements. We have high scale. We need to generate many scenarios. So we don't want to spend a lot of time on instructions. And there's a lot of unknowns. Maybe there's things we want to get, but we don't know how to get them, or we cannot even think of them. With this in mind, which one would you choose? I hope you guys got the drill. So yeah, OpenSCENARIO 2.0, it's a declarative style. It's a goal-based approach. You're actually going to say what you want, trusting the technology, will pick it up from there and automatically generate multiple variations, fresh variations of what it is that you're trying to achieve. In short, it's human readable because you don't need to provide all the instructions. You just set the goals. And it has modern syntax. We'll talk about that. So declarative goal-based, that's the first thing about OpenSCENARIO. Now there is another trick that we use to make it even simpler. So if you look at the scenario itself, there's some stuff, and you'll understand that in a little while, but there's a lot of built-in stuff, the language itself and a domain model. So there's ready-made vehicles and persons. These are part of the standard and will be part of your OpenSCENARIO 2 tools. You don't need to do anything. You can just use them. Now, in ASAM, we invested a lot of time in making the domain model well thought out, very generic, that can accomplish a lot of tasks that we've seen out there. Multiple participants contributing to this domain model. And then there is the user part, which you can create, strategize things to have a VNV package, which is reusable. And then you can take that VNV package and use it for a specific ODD or specific project or specific vehicle model. And so you can very easily modify the generic code to what you need, and you can adjust and tune it for specific scenario that you wish to get. That is something you can do as well. But we have that separation, and we'll talk about it later on, of a few domain experts. If you look at the number of users that are writing VNV packages versus the number of users that are creating the tests themselves. So there is very few VNV packages, domain experts that can accommodate and serve large amount of test writers, which simplifies much more what we need, the amount of efforts and the amount of syntax that we need to learn. And it's also the declarative style that helps. So I can go to any kind of scenario and say, well, the speed limit is 130 kilometers per hour. I don't need to read. I don't need to understand what is the scenario doing. That could be one declarative request that I put on top of the scenario, and will automatically adjust to my request. Or if there's no way to accommodate that, it will tell me you're asking for something impossible. But this is how the user interacts with the machine to generate massive amount of scenarios. So layering, and we'll talk about layering throughout this presentation. In fact, we're actually going to have a short discussion on the concept, and then we're going to have a split. We're going to pretend to be developers and see a little bit of the things that you need to learn as a developer, and then we're going to pretend to be a user and experience the tasks that the user needs to do in order to leverage ready-made content, ready-made, already developed scenario. then a summary and a Q&A if there is going to be questions at the end. So with that, I'm going to jump into the concept. So the first thing we're actually going to recommend is to use a standard language and a methodology. There's a lot of value in that. Selecting a standard, that's the safest path. We're going to have multiple vendors working, creating a full ecosystem around that. That's the best way to support and create assets to use for many years to come. So safest path it is to use standard. It also gives you the freedom to choose the best in class, the best solution. It could be right now, it could be in the future. A lot of vendors will support the new standard and develop things. Some of the things we may know, something we don't even know how they're going to look like. You want to be able to freely select and maybe even choose multiple vendors, each one for its own benefits and its own strength. So that is one advantage. Another advantage of a standard. And there is the idea of collaboration. Here I'm not talking just about users, I'm talking about even tool vendors. Yes, there's a good thing with proprietary languages, sticky solutions, no one can take your customers, but at the end of the day, if you choose a standard language, if you support the standard language, this builds up and allow you to create better, more powerful solution for the benefit of everybody. So standard solution is the way to go. Now, many times standard could be old-fashioned, go stale, or not up to date. OpenSCENARIO is a great comprehensive standard. It's not like that. It's actually pushing the industry forward. A lot of discussion, intense discussion in ASAM, and the result is very, very good. We're going to cover some of these principles. So you want to select the standard. Now, here's something that might be trivial, but not always the case. So we actually need a paradigm shift. We cannot do all the heavy lifting. So when you read about methodologies and workflows, you always read about, oh, there's ODD requirements, and here are the steps that you need, and here's the solution and the platforms, and so on. You're going to need millions of scenarios in order to succeed. And it's not just millions. They need to be smart scenarios. If you, at the end of the day, you'll be doing all the carry, I mean human engineers, creating each and every scenario, and I'm talking about the smart scenarios. If you're going to do that, that's not going to work. We're not going to make it. We need to make that paradigm shift and think, how do we get more automation to help us? That's the only way to move. That's the only way to move forward at the end of the day. And yes, we will need optimizers, which I'm going to talk about later on, and we're going to use all the methodology and the reuse and all of these things. But at the end of the day, we need automation. It must come to that. We cannot just carry all that load on our own. So paradigm shift, that is needed. Here's a little bit about intelligent automation and how things are being done in OpenSCENARIO 2. You can use high-level terms to define what you want. Abstract. You can define an abstract intent. You can be even abstract about the location. I want a junction. I want a T-shaped junction. I'm not being specific in here. So you can choose and you can just say what you want, the goal-based approach. It be very abstract. I will go into more details of what the abstraction means, but I'm not creating each one of these millions of smart scenarios that I need. I'm going to actually deliver that to automation, it's called a constraint solver. And we're going to touch that and go into the details as well. But I'm going to describe a cut-in, what as a cut-in means, and ask the technology either to randomly create cuts-in, but I have full control to say, well, I want an aggressive cut-in, or I want a cut-in next to a junction, or a very specific cut-in in which I choose what I want to control. So full control is needed for that automation. And that is about that. The next principle is random. Random to find the unknown. So it cannot be, Monte Carlo. It needs to be constrained random. It needs to be controlled random. Now, you're using technology right now that was validated using constrained random. 99.99% of the chips in the world are developed and validated using constrained random. And it's not like there was a standard or someone asking them regulation, or you must use constrained random. No, they over time, they hit that complexity like 20, 25 years ago. Over time, they saw that that's the only way to move forward. The only way, if you have infinite amount of scenarios and a lot of unknown scenarios, that's proven to be the case. So finding the unknown using random, that's going to give you diversity. That's going to give you, so we're not, if we're not biased in any way, the technology is going to choose from whatever is possible. It's going to choose some representation. You can control that as well. That's going to surface a lot of unknown scenarios, unknown combination. And it's also the only way for productivity as well. I mean, how else will we get 10,000 variations, which are different from one another? And so that's very important for productivity as well, even if you try to ignore the fact that random actually finds things you didn't think of. So that is about that. So how does OpenSCENARIO do that? There's the principle of infinity mind. So by default, everything is possible. Every possible attribute is possible. Dependencies will take care of. You're going to get meaningful scenarios. But everything is possible. I'm using constraint as directive to kind of direct things, steer things to areas of concerns, to find bugs, as I'm doing my VNV journey. So that's how OpenSCENARIO works. By default, all the attributes are going to be random unless you put constraints on top of them. That's the first level of random. The second level is random mixes. So I can create ready-made scenarios, and now I can mix them in various ways, create a lot of combinations that I didn't think of, a lot of timing and edge cases that I didn't think of. That's what happens in real life, right? There's a lot of participants in traffic, and each one has its own agenda, and eventually things happen. Some things we can handle, some things that we cannot. So we can actually do that in a simulation in the loop. The next level is behavior model, smart agent. These are actually do not have any scenarios or any script they need to follow. I could tell to an agent, you're now a drunk driver, and I can still mix that with some other scenarios that I care about. So, but now we get even the next level of random. We sort of create reality on storms, and we can push things to the corner cases and get more corner cases in a much sooner than what we will get in real life. And obviously, it's going to be cheaper. It's going to be reproducible scenarios that we can reproduce. It's going to be safer. There's many values for doing still for all these things. So you're going to get a lot of unknown scenarios. And then there is the real life random. I want to say something about that. Much of it, if you look at videos, if you look at collision databases, most of the issues you see are actually combination of known things. It's not like there is a donkey with a dress, and there's not like the Enterprise is landing in the middle of the highway, right? It's not that kind of events. It's mixes of known things that in a specific combination were not taken, were not considered, or not enough functionality to handle them. So most of the issues are right here. But if there's something like that, you need to be able to identify something in real life and then take it, identify it, take it to your seal and do more variations of it, run it with checks on, do statistics about it, and so on. So this is something that you can do with the OpenSCENARIO tool flow as well. But that's how we use LibreHCL to get more random, quicker, faster, cheaper. Metric driven, this is very, very important, especially that, you know, we're growing up. We're gonna have millions of scenarios. Well, I don't know what I've tried, what is needed, what is interesting. So OpenSCENARIO actually allow you, syntax allow you to set up the goals. Here are the things I care about. It could be representing the requirements, it could be the regulation, it could be my gut feeling. I actually can write it down in code and have this information be collected and presented for me. So you can actually set and measure goals. This is very critical part of the paradigm. If you want to think about coverage, this is where order, plan, that's a representation of the plan. Milestone, you can have things you want to cover on specific milestones as of the process. Reports, that could generate reports. Where are you? What kind of thing you've done? What kind of thing you haven't done and needs to be doing in the next week? And analysis. All of these management of the entire process, all of that is coming out of the coverage. But we're also combining constraint random. And random is where you're going to have the chaos, the unknown, the surprise, the unexpected. We get a solution that is a combination of the two. Measurement, order, systematic for the coverage, and constraint random, all in the same solution, all in the same scenario. In the scenario, those will be aspects which are asked for, which are measured, and a lot of aspects which are random. So this is about metric driven. And I want to talk about a combination of technology that is needed. So the problem we're facing, and I didn't start by saying how complex it is, because we all saying that and we all understand that. And so for that kind of a problem, you're actually going to need synergy of multiple technologies and multiple paradigms. If you look at scenario-based probability, some people are saying, oh, we need to make our scenarios be based on probabilities, and they are absolutely right, that's what you need. But at some point, if you just do probabilities, an OpenSCENARIO tool will allow you to do probabilities, you're gonna get the same thing over and over again, because that's how probability works. So, well, how do we push things to corner cases? How do we to the edge cases? So you need to break the probabilities for these purposes. So how about optimization? Optimization is like a mathematical algorithm that will analyze, will find interesting starting point, and will start to push the scenario towards risk and see if you're still able to comprehend and react as the requirements ask for. So KPI optimization is like that, right? So yeah, that's a good, very good solution. You want to use that. But what about the unknowns? There are a lot of unknowns condition. Now, with software, not every value can be optimized as well. It could be that there is an if block that just take you somewhere else. If you think about the Tesla incident, right? When there was a trap on its side, the machine didn't even start to stop. It was not like, oh, did we stop fast enough? Or no, it didn't. You cannot find an optimization algorithm that will identify that. And the last thing, well, let's say that the optimization did push for the right things and then make the right recommendation about the speeds and distances. Who will implement it? Who will take these recommendations and create scenarios out of that? If you want to automate that, then you're going to need multiple scenarios regardless of what you're going to do. Well, someone needs to do that. Now, it's either someone, and then human in the loop, which is going to make things slow, or how about the constraint and coverage-driven approach, an engine that will do things for you. And this will also provide a systematic approach as well. So I can see, well, what were the starting point for optimization? What exactly did I try? Right? You don't want to trust that without looking and exploring. And you'll see coverage, and you get randomness, and you can have probability. So we're actually going to need all these technologies and all these approaches, each one for its own strength, working together, and this is what OpenSCENARIO 2 allowed. The last thing we're going to mention is reusable scenarios and VNV package. There's many reasons for internally, and I'm going to speed up just a little bit, internally for why creating reusable scenarios or thinking about reuse as you create something. This is the mindset for any software product you're going to generate, and scenarios are exactly like that. You want to think, I'm going to create these scenarios right now, but I'm going to keep them because I don't want to recreate them over and over again. And you know, with OpenSCENARIO, you can define any scenario, you know, like any scenario for any one of the steps. This is the V model, obviously. You can define all of them. They could work with different test platforms. They can adjust themselves to different seal platforms. They can be composed and reused. And externally, if I'm going to share them, and if I want to change the ODD, all of this is part of the thing we support. So that's abstract scenarios you want to use from step number one. You want to use OpenSCENARIO, and you can use OpenSCENARIO for the entire steps. You don't want to try, oh, let me use some other language and then find out that you're redoing things for the next steps, right? Because you're going to do a lot of these. You're going to have a lot of repetition. Start right for the get-go. Start with OpenSCENARIO. So this is the last one, and packaging is key. I'm going to discuss that a little bit later. Let's talk about the flow of the flow, because we're talking about individual capabilities. Here are the steps that you actually need to take when you do any kind of VNV process. So you're going to define the VNV plan and the goal. You're going to create a reusable scenarios. Hopefully you have self-checking scenarios and KPIs to be gathered and monitors. You're going to have multiple platforms. You'll be able to run with multiple platforms and generate things, and then you're going to debug and see, are there failures? Am I responding, and am I doing the right thing? And at the end, step number 5 is going to be, well, am I testing enough? Did I try all the goals? Did I put all the challenges in front of the vehicle or automotive, advanced automotive function? So that's what you're going to do, regardless of whatever solution you're going to use. The big thing is, well, how much automation can you get? And it's really, that's the whole difference between success and failure. So this is what we're doing at Fortelix, leveraging OpenSCENARIO. And we'll talk a little bit about that, and we're going to go to the syntax. But the first thing is the requirements. We're actually going to look at the requirements, and we have a full flow on how we're going to codify the requirements in executable format. That whenever you run a scenario, whatever scenario you're going to run, all the requirements are going to be measured, monitored, and measured. If something was achieved, whether you intended it to be achieved or no, by accident was achieved, you're going to see that. You're going to see that in the requirement management system. So all the integration is there. And you can add your own concerns, etc. So you can actually define the plan and the goals. And then you can either create a scenario with OpenSCENARIO 2, which we're going to learn in a little while, or we actually deliver vSuite. Because you can create generic reusable scenarios, we create a lot of scenarios for multiple automation functions. You just go ahead and use that. You know, a lot of experience, and we're working with multiple users, and a lot of smartness is aggregated within those vSuite. So you can start with that. You can actually work with whatever execution platform you want. It could be Seal, it could be Hill, it could be other platforms, but we can connect to all of them and make all of them be OpenSCENARIO 2 compliant. So that's with that. We provide multiple KPI metrics and trial failures, show correlation to risk, correlation to danger, what kind of things get me into risk. I should try more of that. We're doing it automatically or allowing the user to actually intervene, do the analysis, and make all the inferences on his own. So this is about failures and coverage, very important things. Did I try all the challenges? Did I do enough validation? And can I move on and declare victory? So these are the kind of things we're doing. The purpose of this slide is to kind of show that OpenSCENARIO is a standard. It's an input format. And many people, many teams, many vendors are going to create different solutions using OpenSCENARIO as a driving vehicle. And if you create your own OpenSCENARIOs or you adopt OpenSCENARIO, you'll be able to get different vendors, each one for the good things is going to develop on top of the standard input format. So that's about that, and these are the things that we're doing. The question about when should I move to OpenSCENARIO 2? Well, answering that with a question, well, when should I sharpen my axe? Before or after or during the work itself? And obviously you want to start soon. You want to start ASAM. So there's multiple vendors that already announced. There is in ASAM, we have the implemented forums that announce different levels of support of OpenSCENARIO 2. You want to check out and select the best one. When you're choosing the solution, when you're adopting it earlier, obviously you enjoy the automation and the robustness sooner. And then you don't, create code that later will need to be migrated, right? So you don't want to create that kind of code, and you don't want to be locked to a specific vendor. Indeed, with OpenSCENARIO, the standard itself, where actually there is a section that explains how to migrate from OpenSCENARIO 1 to the OpenSCENARIO 2, but it's an effort. You need to take that effort. We're going to talk about why this migration cannot be done systematically. You need to spend some brain cycle in order to make the migration, and in specific, the level of abstraction of OpenSCENARIO 2 is higher than what OpenSCENARIO 1 can support. So you don't want to create code that will have to go through migration later on. The tool chain setup does take time, so you want to start early. And what we found out, and I guess it's not surprising, that it's a track down. Many want to use the latest and greatest, and OpenSCENARIO 2 does introduce a very, very exciting opportunity. So many smart people want to move to OpenSCENARIO. So our recommendation, start somewhere there out of option, look at your options and make the selection. So that's the end of the key, the concepts, start language. That's good for you. That's the safest path moving forward. Intelligent automation, to reach scale, you need automation next to you. You cannot do the work on your own, as smart as you are. You want a solution that will be able to find the unknown, but you need to be able to control it as well. This is constraint random. Metric driven, you want to capture all your goals in executable format. You want to get those data-driven reports coming out of that. It will have to use multiple technologies, each one for its own strength and capabilities to get the work done. It is that hard. And reusable scenarios, start thinking about that. How I can create or adopt reusable assets that I can use later on. Highly recommend. Move fast options are available. And with that, I'm going to move now to the syntax. So I can see that there is okay, I will not be able to I see that there's multiple questions. Really appreciate that. I will get to them at the end. So we'll try to do quickly because it's very hard to read and answer at the same time. So I'm going to get to each and every one of them at the end. Okay, so let's talk about the fundamentals, and I'm going to focus on scenario developers first for that. And so let's start with the syntax. And so here's an example. It's a hello world of OpenSCENARIO 2.0. So hello world by the way. That's typically just a small program, the smallest program you can think of the specific language, which typically prints a hello world. But you know, just because it doesn't do anything meaningful, right? But just because it's a hello world, it kind of learn about the language, some of the casual things about it. So here's our first scenario. Define a scenario called hello world that has a single vehicle driving. That's it. That's the only thing we're being asked. Not too much, right? So here it is. So how will a scenario like that look like? And this is a scenario. It's a reserved world, word, and here it's called a hello world. That's a reserved world, and we're just calling it a hello world. And I have the column here. You can see this one. This is just a comment. It's for readability. A tool does not read that. It has no functional meaning whatsoever. Some tools will choose to present it, but you know, in a GUI. But that's it. Doesn't change anything. Doesn't change the scenario at all. And by the way, for ease of reading, I mark things in red. The keywords are in red. So keywords, by the way, there's predefined words that have special meaning for the compiler. So the compiler know that what we want is a scenario and the name is hello world. And that's the start of it. Now we're being asked for a scenario that will have a car in it. So here it is. That's how you do it. And car, and it's a type vehicle. And notice I did not define vehicle. Vehicle, like we said, there's predefined features that are coming as part of the main model of OpenSCENARIO, and vehicle is one of them. So I don't need to define what vehicle means. It's already defined, very elaborated definition of a vehicle. And I'm just saying in this scenario, we're going to have car one. Actually selected the name for it. Not the best name option. I want to use sometimes descriptive names, but it's a name, car one, which is a vehicle. Notice that there is 4 spaces here. There is indentation here. This means that we're inside the scenario. We're actually opening a block and we're describing what the scenario hello world going to have. So there is car one inside the hello world scenario. If I written it here, it would be after the definition. So the scenario world will be an empty one. And it's going to be car one definition, which probably going to create an error message. So these spaces are important, and they mean that I'm actually opening a block and I'm placing car one vehicle within the hello world scenario. So this section is for the scenario participant, but there's the behavior itself. And the behavior here is straightforward. I'm saying serially, though there's only one thing I'm going to do, so it doesn't matter if serially or privately, but I'm just saying car one to drive. Yeah, that's what we're doing. So car one is a scenario participant, and drive is an action. I'm actually activating or asking car one to drive, and I didn't say exactly how to do it because that was not required. It was not part of the exercise at all to say how car one is going to drive. So you can leave that open. You don't need to specify that. Notice that he didn't even say what road am I going to drive, and indeed I didn't specify this as well. This is even with this small example, this is the starting point of the goal, the goal-directed approach. I'm just asking for things or writing things that are being asked. It could be from the requirements, right? Translation the requirements into executable code. But I don't need to, let me select a map, and let me select a location, or let me select a specific vehicle. No, I can just do very quick, short translation of what being asked into code. So that's what we're seeing here. Notice that there is more spaces here because car one is inside the do block, so it's right here. So, and here we go, our first scenario. Now, we defined a real world scenarios, and I could define multiple other scenarios. Well, how do I tell the technology execute that scenario for me? By the way, scenarios can call other scenarios. But how do I say execute that scenario for me? So there is a starting point, and what you see here is one starting point, top.main, which I can extend, and I can just say, well, do the hello world scenario. Top.main is the starting point, starting of execution. And I can call here multiple scenarios in parallel or serially, but that's the starting point. If you want to have something to be called and executed upon initialization, that's where you put it, and that's why we did here extend top.main. So top.main is an existing, you can say, scenario, the starting scenario, main scenario. I'm just extending and we're saying, as well as other things, execute our hello world. Okay, so that's how you run it, and that's all you need. Now I kind of hinted that we don't know what vehicle type, we didn't specify which road we're driving. I hinted that even with such a small example, you can see some of the power capabilities of OpenSCENARIO. Short, concise, say what you want, the rest will be achieved and accomplished for you. So, so that was a small example. Let's move to a more sophisticated example and really visit the concept of the language. So our scenarios is built, our world is built out of actors. These are the scenario participants, you can say, right? But there are abstract entities that make up our world. It could be vehicle, pedestrians, and all of these are also traffic lights or a cone on the road or a person that might be crossing. All of these are actors, and they're going to be participating in the scenarios, performing some actions, as we've seen in the previous slide. But the first thing is actors, and they have attributes. So let's take the examples. Like I said, there's multiple of these predefined as part of the domain model. So they built in, you should expect that out of your OpenSCENARIO 2 tools. So here's a definition, and we're starting from scratch because we want to learn OpenSCENARIO. Here's the definition of a person actor. So let's read that together. So this is an enumerated type. So I can have types in the language. So the gender could be male or female, and there is an age group, which could be child or adult. And here's the actor person, and it has multiple attributes. It's a composite type. You don't need to remember the name, but it has multiple attributes to it. So it has a gender, and it has an age group, and it has an age. So these are the attributes of our actor person. And you can see that it's inside. The spaces are in the right location. Now I can say here, the age is smaller than 120. I just want to make it reasonable. If I'm just going to randomize and the age is going to be 1200, that's not going to make sense not in real life scenarios, not yet at least. So the age is smaller than 120 years. And here I'm saying, well, if the age is a child, sorry, this should have been the age of the child. The age group equals the child, then the age is smaller than 12. I need to fix that back. But that's what we've seen here. So we're defining what is a legal consistent person right now. This is very fundamental. This is very basic, and we'll see how this serves us in real life in traffic scenarios. Extremely important. So the language allows you to put constraint. And remember the infinity minus? So from this the same definition of a person, I could randomize and generate a female child which is 11 years old, or a person which is a male adult of 92 years old. So I can generate that. I will not get a child which is 92. That doesn't make any sense in real life, not with our formal definition of a child or an adult, right? So this is, from that definition, you can generate many variations which are meaningful variations. This is just the starting point. And so, yeah, infinity minus, remember that? Random by default. I didn't have to declare the gender, the age group, and the age to be random. They're just random. You do have a way to log that, but by default, things are random, and that's going to help us a lot later in other phases of the programming. We're going to talk about that. Let's spend a little bit more time about variable. So variables, they use to store information, and you can reference and manipulate them, etc. So the age, it's an unsigned integer. So we're just counting the age, and that could be anything we want. Enumerated type, well, this is numeric, 1, 2, 3, etc. Enumerated type, well, I could have a gender which is going to be unsigned int. Then male will be 1 and female will be 2, or maybe the other way around. But it's much more readable to use string-like values, so male and female, much more readable in a program. So that's why OpenSCENARIO 2 has an enumerated type. You can define the gender to be either male or female. And then we have the compound types. So actor, person has multiple attributes, gender and the age. And the same thing will be for vehicle, for cone that could have a size, etc. So we're basically creating this description that can model reality, and we're going to create dependencies to make legal, consistent, meaningful variations of them. So this is our person. And let's look at the next level, which is action. So actions are pieces of behavior. They're abstract pieces of the behaviors that eventually will make a scenario, right? And so they're pieces of behavior, and they are associated with actors. So a vehicle could drive, a person can walk, and a street light could turn red, and a cone, even though it cannot move, I can assign a position to it. So there is an action that I can perform that is associated with that actor. And they can consume time, they can run in parallel to one another, etc. But then the main building block of scenarios. So here's just an example, and we've seen that before. This is our actor person, and here's an action. See that the red, marked in red, the keyword. So action called walk, and it has attributes as well. There's multiple ways to execute that action. For example, I can walk in different speeds. So we have the speed here and the speed attribute. Again, random by default. I don't say which one. I will put a constraint about what speed is possible and what speed is not possible. We're going to talk about that. The implicit versus the explicit user-defined constraint. So, but that is the definition of an action. That easy it is to create an action. Most of the actors and actions in this webinar, by the way, are part of the domain model, part of the built-in stuff that you should expect out of your OpenSCENARIO tools. Okay, so let's move up to scenarios. So these are composition of actions and other scenarios, because one scenario can call others. They can capture behavior over time using timing directives. So I can say this is running parallel to that, or that runs after this. And I can even do control flows like loop and if. Scenarios are modular, and they can be combined as building blocks. So I can take and create more sophisticated scenarios out of more basic fundamental scenarios. Very important key topic in software development and maintenance, right? You don't want to create everything from scratch. You should be able to take existing blocks and build them and create something more sophisticated out of that. This is what OpenSCENARIO brings, which is new for scenario-based testing. Scenario definition, by the way, is very broad. So it can have vehicle, stationary object, ODDs, right? I can have, well, what is my speed limit? What location can I drive on? etc. So the scenario definition is very, very broad, and you can use and extend even the built-in domain model, which is very rich as well. So let's look at the scenario right now. First scenario, here's a cut-in scenario. That's our favorite default go-to example, I guess. A scenario called cut-in. And here are the scenario members. There's a side here, which could be left or right. There is a road here because I wanted to have a constraint that will say, well, I need to have at least 2 lanes in that cut-in. So here is a constraint. You can say, well, the minimum number of lanes should be larger than 2. And here's our behavior serial, and we're going to have 2 phases in here. So the first one is the get ahead. So I can specify the duration if I want, put range here, and then I'm telling the SUT, the system and the test, this is our ego, you just drive. And car 1, you position yourself 5 to 100 meters behind the SUT at start, at the beginning, and the position should be 5 to 15 meters ahead of the SUT car at the end. So basically saying what we want. We didn't say yet what is the specific location, but we did say something about the road, and we didn't say what's going to be the exact gaps. We didn't say anything about the speeds. So something is going to be selected, that's selected consistently to what we're asking. And here the change lane. So this is the second phase. And now 2 to 5 seconds, the SUT is still going to be driving, and car number 1 is going to, at the beginning, be at the side of the SUT and finish at the same lane. This is what it means, right? We're starting from side behind and we finish up front at the same lane. So here we just describe a full scenario. So using timing directives, I can use serial and parallel. I can even control when things start one versus the other, full flexibility there. And here's the get ahead and change lane, our scenario phases. Now we're using constraint. You've seen like this is a constraint, and this is a modifier. So it's all, it can be read a little bit like English. With a little bit of practice, it just flows very, very naturally, right? You can read it. Position 5 to 100 meters behind the SUT car at the start. Position 5 to 15 meters ahead of the SUT car at the end. So it's also a constraint, right? But it's a more it's easier to read and easier to write such constraint than to write the sophisticated constraint of what's going on behind it. So modifiers, and you have the @ sign in here. I can put a constraint to be at the beginning of the phase, like the get ahead phase. I can put a constraint to be at the beginning of the phase, or to be valid throughout the phase, which is at all, or only at the end, which is at end. So I can say quite a lot of features and controls over the scenario that I would like to produce. So this is our cut-in scenario. It's really sophisticated one. You can see that it's still not a lot of code. If you have to read something like that, that is manageable. You're going to see a few flavors of this. There's serial, there's parallel, there's positioning, there is speed, there is lane, there is several modifiers. But from this set of controls, you can actually create sophisticated scenarios, and you get used to read it very naturally. So this is about that description. Okay, so let's switch gears right now and talk about real scenarios. Now we understand the elements of the language, but we really need to create real world scenarios. How are we going to do that? So first, we need to know our world with its physical constraint and limitation. And let's talk about that. Let's say I want to create a scenario that will be just driving. And I want to be able to specify the distance, the velocity, and the time. Obviously, there is relationship and dependencies between them. distance equals velocity times time. So if I'm going to deliver these three values, they should be consistent. There's multiple solutions for that one, but there's also endless amount of inconsistent, meaningless scenarios. So if I'm going to create, using everything we've learned, right, a scenario like this, look at this. Here's where I can do that. I am not even naming the scenario. So extending top domain, here's what I want to do. I want car one, I want the STT car to drive for 3 seconds, the speed to be 400 meters per second, and I want the position at the end, remember this, at the end to be 200 meters. So I can specify something. Now, this is not a good scenario. This is not a meaningful scenario. It's really hard to predict what will happen. And I hope you can see why, right? Because 3 times 40 is not 200. And this is why we're saying, here it is. So this is where we're saying that if you want to assign values to each one of the documents, that's going to take time. You'll have to use your personal calculators. And then these are not, I started with the most basic scenario, obviously, but this actually grows on you. Like for example, you need to make sure that the road segment is big enough, right? Is it 200? Did I show something that is 200? Because if it's not, then yeah, that's meaningless scenario. The speed, if you're going to do real life scenarios, you're probably not going to drive 200 kilometers per hour inside the city. Probably want to make it reasonable. So you will do that if you're human, but we're trying to automate things here, right? Now, if I want to control the acceleration or deceleration, these are also connected, obviously, to distance, velocity, and time. The acceleration is the gap in velocity divided by the gap in time. But so you need to make sure that you do that, and you need to do that for each one of the participants. And it's also the scenario participants, and also if you're working on a track, well, the track can accelerate differently than a roadstar. So if you're looking for edge cases, and you're going to try to force a vehicle dynamics that is not supported by the vehicle you're trying to control, that's going to be meaningless. It's hard to predict what actually the simulator is going to do with that, but that's not what you wanted, not the values that you selected. So you need to take the vehicle dynamics into account. Now, all these dependencies are really hard to predict. Here, let's look at this example. Let's say that we're in the cutting and we want to control the change lane duration. How fast is going to take me to move from one lane to the other? Well, they're actually even there a constraint. So I can move laterally either a third or less than what I move longitudinally. So if I move 3 meters forward, I can only move 1 meter laterally. That's how things work. So I must control the speed if I want to make a fast enough change lane. That's how things work. Now, there's going to be many, many other considerations that you need to take into account if you want to systematically generate something. So concrete scenarios, just to summarize, hard to produce. You have to use your fingers, you have to use your brain, you have to use calculator to find out something that is reasonable. Usually there's a trial and error process involved. Otherwise, meaningless scenario. So for some special simple things, yeah, that's great. For other things, we need a lot of smart tests, and we cannot spend all the time to resolve them for each and every scenario. So how about using ranges? It's a good thing you ask. Well, what about ranges? I'll use a range and a technology find a solution for you. Well, that is great. What I did here, I sort of created, and some of you know the term logical scenario, and some of you not, but we're going to all learn that. It's a logical scenario. So I took not everything, but a lot of the dependencies, I took them outside, and you can see that all the attributes right now are either get full value or they get a range. So you see, I didn't determine the position and the duration, the speeds. I didn't do all that. There is a range, and now technology can pick and choose, and I don't use my brain. And enough things I still need to do. So that's great, right? Productivity. Well, wait. The technology you're using should be able to select consistent values, set of values. Otherwise, you're going to get a lot, but a lot of meaningless scenarios. So you need some kind of technology that will take the ranges and find the consistent sets out of the many, many inconsistent scenarios. And actually, there's tons of scenarios in that logical cutting scenario. And this is just ranges, right? I didn't do, by definition, by the way, the formal definition of logical scenario is that you can use ranges. There's just ranges in here. There's a little bit more, but there's just ranges in here. Still, if you want this to be automated, if you want to get a lot of meaningful scenarios, you need to use a constraint solver. It's not even just removing things. You really need to calculate things up front. I'm not going to go too deep on the technology and why approximations are not so easy to produce, but a constraint solver, that is a piece of technology that is going to take all these requirements, but take a lot of the implicit physical, the law of physics, and make sense out of it, create a scenario, and there's endless amount of scenarios I can create out of this, but I need them to be consistent to get a meaningful scenario. So that is a constraint solver. It's an AI technology that basically needs to be adopted. So a constraint solver is needed for logical scenarios. Otherwise, you'll get a lot of meaningless scenarios or really hard to predict what you're going to get. So this is logical scenarios. Logical scenarios are supported by OpenSCENARIO 1.0. It's not even something that OpenSCENARIO 2 brought to the table. You still, if you want to be productive, if you want to be effective, you need to use that. But that's how you spell it out. This is not enough. Okay, we said ranges, we said constraint solver. What else is missing? Well, what is missing is what we're trying to achieve. Well, I'm trying to follow the requirements, and I'm trying to follow the test plan, and I want to intelligently search for the bugs. Is these kind of constraints, these kind of ranges are going to be enough? And the answer is absolutely no. So this is our VNV journey. We're going to search for the cracks, right? We don't have a full map of where the bugs are. We're going to learn from experience. We're going to take the requirements, and we're going to take the test plan, our gut feeling. These are going to be maps of where we want to search. But then we need to, let me push a little bit here. Let me go faster. Let me go slower. Let me cut the distances. I want to challenge in this smart, intelligent way and search for these bugs. You're going to need all the control you can have, and it's going to be hard. It's going to be hard anyway. So this is not enough, and this is what abstract scenarios bring to the table. Abstract scenarios provide a lot of control nodes, which are key for you to achieve your job in an effective and productive way. So it allows you to steer the scenarios with user-defined constraints. It's no longer the physical constraints that are implicit. Now you, as a user, can say, what do you mean? Well, what do you mean with cutting? What, bigger than, smaller than, locations, ODD constraint? Yeah, bring it on. You have now the tools to describe it. Cross-attribute dependencies. I'm faster than this. And I can say how much faster within a range, but I'm faster than. That is abstract scenarios. It's controlled unknowns. We're still going to do, logical scenarios. I can ask for all the iterations. But this one is controlled with all dependencies. Now I want to try things with all speed, with all distances. I'm going to push things for the edge case. It's controlled. I have accuracy here to search for those paths. You can use composition. Composition comes only with abstract scenarios. Let me explain why. Let's say you have an oncoming scenario, and a carrying scenario, and they're logical. Logical scenario, by the way, you cannot put location in logical scenarios. It's a formal definition. We can explain why, but that's the definition. And if I want to do oncoming and a carrying in the same scenarios, if I put them together in the same environment, I'm likely to get nothing useful. Why is that? The logical could be going to, the carrying could go to one location, then oncoming can go to a different location. Now I'm trying to do the two of them at the same time. They're not going to come close to one another, not in timing and not in distance. You need to have some kind of solver that will choose the right location for both of them to work with and then make them close to one another. And this is where you're actually going to need a constraint solver as well. Sorry for the repetition. And eventually reuse the ability to define generic scenarios and put constraint to steer them to OBD, steer them to locations, to my vehicle dynamics of this specific project. That is abstract scenarios. And the optimizers, like I think I said it, but let me try to repeat that. If you have an optimizer, it's going to do all the math in the world. It's a perfect condition. It's going to suggest something. Well, how are you going to make sure that where you selected some attributes, the others are consistent with what you selected to control, right? Who will do that for you? So again, I said it, right? You need a constraint solver. You need abstract scenarios to be able to express it, and you need constraint solver to do all the consistency validation. So just a few things that you define and declare a scenario, going always with the same example. You want to factor out interesting and frequently used control nodes. As a developer, you're creating a reusable scenario. So you want things to be nice. You want the user to be able to very easily identify what needs to be done and control that. And you need to use wide ranges. It's still, there's some things which are controlled. Some things are important to do all combinations of, right? But now you have full control of things. And there's default constraints and preferences that you can use as well. So it's still generic. I can still serve a lot of requests, but there's some, here's what happens. And by the way, default constraint and preferences could be distributions, right? I can say what kind of distribution I expect to get unless something else is specified or depend on. So this is about that, factoring out control. We already covered that. If I have a carrying scenario, there's some physical limitations or physical requirements of carrying scenarios. Where can it take place? And what we want to do is, like the carrying scenarios, we will automatically identify without us explicitly asking for what kind of locations could be for a carrying, and then just run the carrying accordingly. So just to repeat that part, concrete scenarios, you must assign all the attributes. That's going to be a lot of work to create meaningful scenarios. Logical scenarios, this is where you can either assign and use a range, fully specified range. And like we said, you need a constraint solver even for that. And abstract scenarios, this is where you can actually have full control, any constraint, including location, cross attributes, timing control constraint. And functional is non-formal semantic. It's typically being confused with human natural languages. You can have human natural language that are formal. Functional is not formal by definition. And these are the three flavors: manual, tedious on the left-hand side, going all the way to automated, scalable on the right-hand side. Constraint solver is needed for both. Again, sometimes you see logical scenarios, but there's no constraint solver. There is a consideration there. And I want to say something about coverage. And because there's a lot of syntax, it's going to be very short, but it's very, very critical part of the solution. So I can now go to my cutting in slow, and I can say, what do I care about? What are the goals? Because there's going to be a lot of values that I don't care about. But I can be very, very specific with the things I care about. I can decide. I care about the side because I want to do cutting on the left and the right, and the car kind. I want to do a cross. I want to try all car kinds or car types from all sides. I put out the speed, and then I care about some specific ranges more than others. And I'm going to speed up a little bit, but you can see what's being defined here. So this is where I'm saying I care about 10 to 130 kilometers per hour, but every 10 is going to be a category of its own. So I want to have one representation of 10 to 20, 20 to 30, 30 to 40. I can change the target. Very, very flexible, and I will get a report of what is exactly was tried and what was not tried. So this is covered, again, very critical part of the process. This is where the management can, the reports, this is what as managers we would like to see. How deep did we go? How far did we go with that effort, and what is left? And maybe we need to shift resources. There's much more about that in automotive requirements-based testing, and there's webinars about that. I kind of mentioned that before. As a role as scenario developers is to create these reusable scenarios and use them. So, and you want to produce generic scenarios that could be applicable to multiple conditions. So use wide ranges. You want to master the topic and aggregate knowledge and expertise within the scenarios. So I could be a master of, we'll make a funny example because we use the cut-in scenario. Then I will learn what kind of cut-ins are really challenging for automotive technologies. And I will put scenarios, control nodes about that. And then I put coverage goals on top of that. And then many users can leverage my expertise and my exploration on that one. And it's a simplify the scenario tuning for multiple users by creating those control nodes. And yeah, OpenSCENARIO 2 with proper technology facilitate these critical activities for development. Again, more information. We are embracing reuse to boost your productivity with the ASAM OpenSCENARIO 2.0 webinar. There's much more that we share about that one. So we're done with the developers, which took most of the time. Let's spend a little bit time on what the users are going to do. So here we are. We're just going to get a package, a pre-packaged scenario, and we need to do things with it. So the first thing is going to tune that package for my project, ODD, my vehicle model, whatever it is that I have in mind. Then I'm going to adjust the scenario to my own requirements and preference. This is very critical. We hear a lot about users that were saying, oh, you know, I don't want to use ready-made packages. They're built for some requirements. I have my own requirements team. I have my own a test plan that I need to follow. Well, this is a key thing. You should be able to get scenarios that are not locked to any map, and you can adjust them to your own needs, make them your own, following your own preferences. And you need to be able to tune coverage requirements. Adjust checks and thresholds. What consider a failure? What kind of things are you committed? It could be a business, right? Consideration that will change what you're committed to. So you can adjust the tuning as well. So there's nothing new I'm going to teach you actually in this section, because it's going to be exactly the same powerful features that's going to help you do the scenario usage. It's just going to be less of it with minimal amount of knowledge. So for this, we are using the aspect-oriented programming, which is a paradigm that allows and to increase modularity by allowing the separation of cross-cutting concerns. And I'm sorry for the long words and the fast reading, but it just means that everything is extendable. And if you connect that to what we've seen on the declarative style, you can just say what you want. Ignore what's in there. Ignore how the implementation is and how complex it is. Say what you want. And if it's possible, if what you ask for can be accommodated by generic scenario you adopted, you're good to go. So here it is. This is our generic scenario. And on top of that, I don't want to use configuration constraint or test constraint or execution platform. Not all the simulators will be able to support all actions. Or team concerns or SAE level, because now it's SAE level 4 and not level 2, so things could work a little bit differently. That is very easy to do with aspect oriented. The only thing is you just extend things and add whatever constraint you want to whatever layer here. And the nice thing on top of the generic scenario, the nice thing, everything is going to be reconciled and consistent if it can be. Constraint solver will take all these considerations and just find the solution for you. And not only it is powerful and automated, it's very simple. That's the brilliant thing about it. If you want more information and reuse, there's much more that we've discussed in the other webinar about that. But here's the scenarios. Let's say that we didn't learn, we don't even know how to read it. That's some kind of a cut-in. I can still extend. I want on top of the cut-in, whatever it does, I want the side to be right and then the change length duration to be 2.4 seconds. Now, I don't even know how things are implemented. I can still ask for it. And let's see if my generic cut-in can accommodate for it. I don't need to learn all these things. And it's the same constraint and modifier that the developers are using as well. Very simple, very few lines of code to get where you want to go. Many things are extendable. I can extend an enum. Maybe there is a country, Japan, and I now need to drive on the left. I can do that very easily, extend something that was not built to support Japan and do it like that. And here, just countries, there's more examples. You can also extend coverage. So I can take a coverage definition and say, well, my goals are different. Obviously, it's going to be different. My requirement teams came up with these goals. This is my requirements. So it's very easy both to write the requirements definition to begin with, and as we said, as experts developing reusable scenarios, we want the coverage to be as smart as possible, just pointing to the things we care about and ignoring the rest. But I can still, you see the override? So cover override, whatever was there, and now I want to ignore VRU vehicles and truck. I'm just extending and I'm ignoring, I'm overriding the definition to match. And I don't know how things are implemented. I may not know all the language features that are being used for cutting. I can still do that from outside with an extension. So for scenario users, yeah, there's basic that you need to learn. But the main thing is to select proper reusable scenarios. You're going to see the catalog of scenarios that they can be controlled, and it's minimal amount of knowledge and minimal effort to control these with open scenarios. Improve your flexibility to follow the requirements and allow any maps and ODD needs. Just a few examples. If you adopt open scenarios that were developed properly. Yeah, so this is for the scenario users. And yeah, you've seen the features. We're talking about very few deep, powerful features that are being combined now to support both developers and users. And let's get to the summary. I'm going to mention our offering, our unique offering, and what I wanted to say. You see here, you can write your own scenarios. We have a very good engine for many years, and we're working on that. And we have a lot of ready-made scenarios, really tons of ready-made scenarios for different ADAS, level 4, mines. If you're interested, come and ask us. And then things are going to run. We're going to run with the platforms, and we collect all the information, give you reports. You can have customized reports, all on the clouds, all massive scale. The thing I wanted to say, what's unique about Fortelix offering, that we can make any simulator or execution platform OpenSCENARIO 2 compatible. So whatever simulator you have, or homegrown, commercial, we can enable and make OpenSCENARIO to work with it. Either it's already integrated, or we need to have some integration period to integrate it, but it could be supporting OpenSCENARIO, and your homegrown simulators will support OpenSCENARIO exactly like commercial. You'll be able to use the same scenarios on both. So that is unique about that. I have sort of I didn't do a demo because I thought we have too much information, but here it is. This is kind of, we're starting from the requirements. We can convert the requirements into the goals. These are the goals. You can see the structure as concerns and sub-concerns. From that, we're generating the scenarios, and we're running massive amount of them, in this case, with NVIDIA Drive Sim. And this is going to use the same cut-in scenarios, but you can adjust it to your own ODD, to different locations, to different concerns, following your requirements team agenda. And you can see different cut-ins happening in different locations. So this is what drives in here, and you can have different flavors to track up front also. And with a slower, I guess, change of lane. Now we're running massive amount of scenarios, all of them meaningless, all of them created. We're reading in the result. KPIs, goals are being measured that I'm actually not, I'm following the requirements and the expected behaviors. And all the information is imported to requirements management tool for you to manage your project. You'll see exactly how many scenarios were generated for each requirement, how many were failing, how many succeeding, everything is fully traceable. Okay, so this is about that. I took that moment, and that's the summary slide. So if you wish to learn more, if this is interesting and you need to learn more, you know, we have fortelix.com.resources. You'll see there's multiple blogs, and there's going to be webinars, adding more and more webinars inside. If you want to contribute to OpenSCENARIO, I'm writing OpenSCENARIO because the plan is to take OpenSCENARIO 2, convert OpenSCENARIO 1 into it. It's going to be following the OpenSCENARIO 2 syntax and domain model. Join ASAM. You know, you can contribute. You can make sure that your requirements are being taken into account and being served by this standard. And if you want to see how this is going to work with your specific requirements, with your specific needs, email us to info@fortelix.com. We can do customized demo, even the evaluation, it's not very painful. We have really deep training that go into more of the principle and more of the capabilities. If all of that is interesting, yeah, shoot us an email. And I know it's info@fortelix.com, but you'll get answers right away if you send an email. So yeah, with that we're done with the content, and let's read through some of the Q&A.
Thank you very much, Sharon. Thank you very much. We'll give you like a few seconds to read through the great question that we got. So, you know.
Okay. So Johannes Schmidt, I hope I'm pronouncing the name okay. I get the idea, but why does it have to be a new language, which I first started to learn? Why not incorporate the exact same ideas into a Python library? What advantage does the DSL approach have over a library-based approach for this domain? So I tried at least to cover that. Python is a procedural approach. You just need to program everything you want, and you're going to get just the thing you program. What we created is a domain-specific language, which is declarative or goal-based. You say what you want, and there's going to be a lot of processing, a lot of automation, doing things in the background, making sure you're going to get what you want, or give you, you know, feedback that your request doesn't make any sense. So that's why it's a domain-specific language. It's like the driver, right? I can either provide all the instruction to the driver or just give him the address. And the decision, intense discussions, and this was something agreed upon, that we're going to have a declarative approach solution. And we'll optimize and recommend road profiles, map location where bugs are likely. So there's different algorithms for optimization and what they can do. yeah, there are some that going to find this kind of correlation and try more of that. Definitely with the approach that we're recommending, which is a combination of optimization and random to begin with, and the coverage is going to give you enough good starting points, right? So you're going to try things in different curvatures and different speeds, like. And then from that, the optimization is going to be used. So you're going to get random combined with the mathematical optimization. So yeah, you get, like we said, right, the combination of the technologies. And Katsuhiko Sato is asking, what is your definition of random scenario? Is the same as edge case? Well, you can have a random scenario that is very typical and nothing interesting in it. And there is scenarios which are edge cases. And edge case definition is, something out of the ordinary. Sometimes is a very fast speed, very slow distances. Could be different kind of edge cases. So random does not necessarily give you edge cases. With the coverage, you can define, here's the edge cases, right? Translate all your fears, the map of all your fears, translate that into coverage. And now that is a technology that you'll have to put in place, but it will automatically go after the edge cases you thought of, and it's going to create other rare things maybe that you didn't think of. So yeah, a random scenario could be an edge case, corner case, an extreme or dangerous or interesting scenario, or it could be something very boring as well. So you need to have that kind of a control, both to make a legal consistent scenario, but also an interesting scenario. There is there is another question which is about the same. Can we say do car one do drive? Yeah, we can. So do is the first keyword of the behavior of the scenario, and you can say car one. You can either say serial, parallel, or just activate some action. You can do that. I was trying to just use serial and parallel most of the time, at least, just for consistency and because we're starting. But you can avoid that if you only want to call one scenario. There is why should we set the gender in traffic scenarios? I don't know. Maybe I just took that example, and actually someone made that comment before. This is up to you. Up to you with your requirements team. Do we want to make that distinction? Is the hairstyle important? Not important? If I'm into the face, looking to the left, looking to the right. Maybe there is some something to do with the perception that you would like to check. That is up to you. We're basically providing the tool, and you decide what to do with it, the capabilities. Kudo, how would you describe? By the way, thank you. Well, there's multiple questions, so thank you so much. Kudo, how would you describe building blocks of the cut-in scenario in OpenSCENARIO 2.0? So it could be that you describe coming from behind as one building. It's up to you. This is software modeling, right? How do you choose to break or decompose a scenario into sub-elements? So it could be that, cutting is a basic, fundamental, elementary scenario, and I'll just use cutting. And this cutting will be combined with other scenarios like cutting and oncoming to create more sophisticated scenarios. But it could be that I'll decide that cutting is built out of start behind, change lane, and I don't know, maybe slow down. So it could be that it's a modeling decision that a developer can take, whether cutting itself is an atomic building block or to decompose that. But you can decompose that if you want. I think in our library, a cutting is decomposed and it's built out of other scenarios. And we have cutting and slow, which is going to be a combination of 3 scenarios. Beyond the language specification, is the constraint solver solution part of the standard? Is it freely available? So the answer is no. The constraint solver, the simulator, everything, you know, that's not part of the standard. The standard just defines the input format. What should it be? And by using that, by both vendors and user using that, I can actually adopt multiple solutions. I can move between solutions, etc. But it's up to the two vendors to compete about what constraint solver do I have, what kind of coverage engine do I have, what kind of check-in solution do I have, what kind of simulators, sensor models. All of that is something that tool vendors will compete on. The standard just define in a very formal way how they should behave. So you as a user will be able to change vendors if you wish to do so. There is another question, and I'm reading them with you. In this context, a test case, for example, includes a driver pressing a button in the car, activating, deactivating, driving function. So Johannes Schmidt make that question. I'm not sure I fully understand it, but let me just say something like that. OpenSCENARIO 2 supports HMI. So it supports the driver pressing a button, activating some ADAS function in the right time, the wrong time, etc. So it's definitely can be, and I don't know which test case were you talking about, but it could be part of this scenario. And you could activate and have the driver or other car participants or car and the people that are in the car opening the door or something like that. So there's a lot that is part of the built-in, the domain model that I mentioned. But you can also, and this is part of the standard itself, you can also extend that and add something that is not there. Maybe you thought of something, or you have a special button with special functionality that is not part of what other provides. So very easy to extend, add, and create new scenarios from the new functionality that you have in mind. So that is the answer to that one. It could include driver activating or deactivating driving. For the exploration, Lev Sorokin is asking that. For the exploration of possible concrete scenarios, when a range is defined, is it possible to plug in an own search algorithm when using OpenSCENARIO 2? So there's multiple ways. You definitely need something that will solve, with a logical scenario. And by the way, if a concrete scenario has a range, it's considered to be a logical scenario. So in a logical scenario, yeah, you need something to resolve all the dependencies, right? The physical dependencies that are there, and you need to resolve them for meaningful scenarios. And search algorithm, I don't know what it means. There's different kind of ways to approximate, but constraint solving is a well-known domain in computer science, and you need that. Eventually, you'll need that, and the approximation will not work out. Like the search algorithm, I don't know what exactly you mean. Constraint solver could be considered to be a search algorithm, but that's something that we as an industry will have to grow into with Fortelix, where we have experience like 20. I think I have 26-year experience with constraint solver, and just people with more experience than me in this company. So we're doing that for a long time. But yeah, I don't know what search algorithm you mean. It could be a constraint solver. So, and leave you with that. There's another anonymous question to elaborate a little bit on constraint solver. I don't want to go too much into technology detail. That was not the purpose. I kind of said a little bit about that. It's part of artificial intelligence. And like I mentioned, all the sophisticated smartphone or tablets, or they're all well validated with the constraint solver, all of them. And that's the only way that proved to be valid and delivered. There is Johannes asking another question. I don't get it. Does OpenSCENARIO 2.0 include test case specification or what? So OpenSCENARIO 2 just delivered the building blocks. So it delivers the ability to create actors and action. Remember, person and vehicles. It's actually deliver in the domain model some elements of an actor, a person, sorry, or a vehicle with their attributes, etc. It's a very broad starting point, but you can enhance it from there. From that, you can build your scenario, call it test case specific, and you can build your own scenarios. They're not pre-provided in the standard itself. We have a lot of methodology on how to build them, how to simplify things, how to make them generic for multiple usages, how to make it simpler for scenario users, etc. So, by the way, there's much more. There's much more question that being asked. I will have to stop here because of time. Thank you everybody for attending this webinar. I guess you will be able to access it if you wish afterwards. Dan can say more about that. But again, thank you all for the time.
Thank you very much, Sharon. Thank you very much, everybody. We kind of overstretched our webinar for today. This is once again number 4 in a series of our experts webinars. They're all available on our website, and we will of course send you a link to a recording of this webinar. Until next time, thank you very much, and thank you, Sharon, for a great webinar. Good evening and the rest of the day to everybody. Thank you.
Thank you. Bye-bye.